Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving apply operations to maximize score. So the problem states that we will be given an array nums of n positive integers and an integer k. Initially, we'll start with a score of 1 and we want to maximize our score by following the operations at most k times. So for each operation, we can choose any non-empty subarray in nums that we have not chosen previously. And within that subarray, we want to choose an element x from there with the highest prime score. And the prime score is just an integer x that is equal to the number of distinct prime factors. So for example, the prime score of 300 is 3 since it will contain 2, 3, and 5 in their factors. And if in the subarray, multiple elements have the same prime score, then we will choose the number with the smallest index. And then we want to multiply our score by that number. So if we look at this example, we will perform two operations. The first operation, we can choose from 2 to 2 since 9 is the largest. So we'll multiply by 9. And for the second operation, we can choose from 2 to 3 since it is another subarray, but we will choose 9 since they both have the same prime score, but then we will choose the index on the left. So we'll multiply by 9 again, and 9 times 9 equals 81, and that can be our result. So we will return 81 for this example. So now that we have seen some examples, let's get to how we can solve this problem. So this problem is quite long, so I have already set up a lot, but I'll go ahead and explain it right now. So first, we will calculate the scores array, which will contain the prime scores of every element in this. So as you can see, 19 only has 19, 12 contains 3 and 2 as their factors, 14 contains 7 and 2 as their factors, 6 contains 3 and 2, 10 contains 5 and 2, and 18 contains 2 and 3, because 2 times 3 times 3. And you'll see more how we calculate that in the coding section, but basically for each number we will iterate through from 2 to the square root of that number, because the factor will never be greater than the square root of that number. So we just only need to iterate from 2 to the square root of that number. And as we are iterating, if we find a prime factor, meaning dividing by the prime factor will give a remainder of 0, then we will increment the scores of that index by 1 each time. And we will do that for every number in nums. So next, we will calculate the left and right array, and we will do that using the monotonic stack. If you don't know what that is, feel free to look it up, or you can just look at how I implement it later in the coding section. But basically, the left will be initialized initially with all -1, and the right will be initialized with every element as the length of nums, which would be 6 for this example. And for the left, it will basically tell you the leftmost available element, and similarly, the right will calculate the rightmost subarray where you can contain that index towards, and we will use these two to calculate the subarrays. And basically what subarrays will tell you is the number of subarrays that you can make with that number. So as you can see, at 19 you can only make one subarray, at 18 you can only also make one subarray, but at 10 you can make two subarrays because you can be 10 to 10 or 10 to 18 because they have the same prime score, so you can make 2. At 6 you can make 3, obviously it can be this or 6 on its own. So we will use the right and left to calculate subarrays, and how we will calculate that is we will do the value on the right minus the index on the right times the index on the left minus the value of that index on the left, and that should give us what we want here. So for example, if we want to calculate this one, it would be 6 minus 5 at index 5 and index 5 minus 4. So they both equal to 1. 1 times 1 is equal to 1. So that's why we have 1 here for this example. And after setting up subarrays, we can set up a min heap where the number will represent the number in the index, but we will make it negative because it's a min heap. So we will have to make it negative and change it back to positive later. And what we will do is before k becomes 0, we will continue to pop from min heap and look at subarrays to see how many operations that it can perform, and then multiply that number in min heap by the number in subarrays times. And whatever the number of subarrays is, we will subtract it from k until it becomes 0. So let's go over real quick. So first we will pop 19 and we can multiply by 19 one time. And now 18 is the largest we have. So we can pop 18 and multiply by 18 one time. And also, as we see, we are subtracting k by whatever in subarrays each time. And now the smallest element is 14. 14 is in index 2. We see that we can do it 4 times, but we only need to multiply by 14 one time since k is only 1. So we'll just subtract by 1 and multiply it one time. And now that k is 0, we can return this 4788 as our result. So the time complexity would be O of n times rad m plus n log n. So the n log n will come from min heap, and the n times rad m will come from when we are calculating scores. So n would be the number of elements in nums, and m would be the largest element in nums. Because when we calculate scores, we will have to iterate through nums, and for each nums, we will have to iterate to the radical of that number. So that's why it's n times rad m plus n log n. And the space complexity would be O of n, because all of these arrays would take about n space. So now let's get to the coding part. So first we will set up mod in case the result's too big. So 10 to the power of 9 plus 7, and n would be length of nums. Scores would be initially 0 times n. So we will now loop through n for index and range n. Nums equals nums of index, and for every factor in range from 2 to the square root of num plus 1, if dividing by it will not give any remainders, then we can increment the score. So scores of index plus 1, and while we can still divide by that factor, we would continue to floor division by that. So num floor division factor, and afterwards, if num is greater than or equal to 2, that means that itself is a prime number, so we will increase it again in the scores of index plus 1. And now we can figure out the right and left array. So right would initialize as n times n, left would be -1 times n. And for I in range n, so while there is a stack and the last element in stack and the scores of the last element in stack is less than the scores of I, then we would pop from that index, and then we would set the right side of that index to I. So right of top index is equal to I, and if stack is there, then we will set the left to the stack of -1 of that index, and each time we will append I to stack. And now we can figure out the subarrays. So initialize to 0 times n, and for each index and range n, the subarrays of I would be the element on the right minus the index times I minus the element on the left side, so left of I. And now we can get to the min heap part. So initialize min heap to empty, and for index and range n, we will push the element and the index to the min heap. So heap push min heap with the negative. Make sure it's negative because it's a min heap, not a max heap. Python has min heaps, so we gotta make it negative and convert to positive later. So initially the score is 1, and while k is greater than 0, we will pop from the min heap. So num and index is heap pop of min heap, and we need to change the number back to positive. So num is equal to negative num, and the number of operations we perform would be the minimum of k, or the subarrays at that index, and the score would just be the score times, we will use the power function of number operations, and if it's too big, we will add a third parameter mod, and multiplying by score, we need to mod it again just in case, and subtract k by the number of operations, and then we can return score. Okay, let's see if it works. Okay, perfect. Hope this was helpful. I thank you all for watching. If you have any other questions or comments, feel free to leave it down in the comment section, and I hope to see you all again soon.